Hi, my name is Phuc Nguyen, and today I'll be talking about a recent hackathon that I went to with my friends, Rachel Lilja, Bowen Yang, Lee, and Annie Lian. So we went to Hack Georgia Tech or HackGT, and there at HackGT they have multiple challenges, and we chose to tackle the Siemens healthcare challenge, and we managed to win it. So I'll talk about the application that we did and the inspiration behind it. So their challenge was to tackle healthcare in a new and innovative way. So when we thought about healthcare, we definitely wanted to focus on the pre-screening because that's where people can save a lot of time and money if they're able to kind of just pre-screen themselves ahead of time. But people don't have time, like, or the money to just go in and get a screening like once a year for like every year, right? Because you have to set up an appointment and take time off work and pay a copay, or if you don't have insurance, then that's obviously an issue. So the idea behind the application is web-based, and so that users can just use at home whenever they're free. When they get off of work, people get off of work at like 10 p.m., midnight. Just at their own convenience, and it's a lot cheaper because ideally it would be free and open to the public. So first thing first, we have we use Clarify to which is a neural net, and we train this AI to detect two type of eye diseases, which is cataract and glaucoma. Those are the two most notable and easiest to detect through image recognition. So the idea behind this is definitely that there are a lot of health issues that you can detect through image recognition, and the application for this is huge because it can be applied to like snake bites, bug bites, and like rashes and other type of things, other type of health issues that I don't know of. So our data set for this is definitely small because we manually go out and find the pictures on Google Images, and we try our best to find the ones in early stages, but it's definitely a lot harder for us who have limited access. So if there's like a big partner that comes in, like the CDC, with the huge amount of data that they have to train image recognition machine learning, then it can be huge because people at home can just upload images of like their bug bites, because the bug bites have specific patterns to them, and so the AI would be able to detect what type of bug bite that is and recommend a course of action. And a lot of bug bites you don't actually need to go to the doctor to, since all they do is you're literally going to the doctor to identify what type of bite it is and what type of cream to put on it, and a machine can do just that, and at the lower cost of money and time, right? And so that can also free up the doctor's time to focus on more important matters. So the application for this is definitely huge. We don't have this up in a web app, but ideally people would just be able to upload pictures of it, but we don't have it up because it is an API and it's a free key that we're using, and we don't want to be charged. So then I'll also show the next thing that we also built is an online eye vision test. Now, we looked at a lot of eye vision tests before we started building our own, and there's a lot of problems that the current ones have. They make you manually measure out your distance from the screen, and they make you use the mouse to click on what the letter you think it is or what direction that you think the letter is. And to me, it doesn't make sense that you would make a user do that, because you can't really trust people, or like you can't expect people to accurately know how far 2 meters back is, or and then even if they manage to like measure that out, being 2 meters back and using the mouse click does not make sense at all. So what we do is we automatically scale the letter, and so to do this scientifically accurate, to make it scientifically accurate, we use the webcam and a node package. It's called tracking.js to detect the distance between your eyes and use that as a scale, and the angle that you're looking at the screen, to then find the distance that you're at from the screen. And then that scales down the letter, and that's the scaling is all based on the official Snellen's algorithm, and the official Snellen chart. And then we also use voice recognition to detect the letters, because that makes way more sense than having users click on what letter it is. And Bowen here is gonna demo to you the process. And you can also go to this link right here. It's yang9.github.io/hackathon/nyang/index.html to play with it yourself. That is open because that is a script and we don't need an API for it.
Okay, so when you start the page, it's going to look something like this. Now, when you click Allow, it will give you webcam access, and you would be able to see what you are going right here, how it's recording. There. Now, you can see the distance between my eyes right here. So if I come closer, and then I start the camera, the letters should be smaller. It's very small. Now, if I reset and I start from over here, you can still see it on my eyes. If I start from over here, the letters are bigger than before. And then the voice command will be like letter T, letter O, letter E, letter Z, letter E, letter N. Then when the letter gets too small to where I can't read it, then I would have to guess, most likely wrong. Letter A, letter A, letter A, and then it'll give me an eyesight. Now, if you decide not to use the camera, you can click on block right here, and you can enter the distance in meters, say 2, and then it will automatically calibrate. So cover one eye, letter P, letter E, letter F, letter A, letter A, letter A, and there's your eyesight.
Okay, so as you can see, like, he was able to just move back and be as comfortable of a distance, and just use the speech recognition. Is just a lot better of a process, and it's a lot better of a user experience as well. And of course, we provided users with a way to manually put in their distance if they're not comfortable with the webcam. So that's all I have today. We won some pretty nice ZenWatch from ZenWatch 3 from Siemens, so that's pretty awesome. But that's all I have. Thank you.